Hey guys, now that you've taken a look at some of the celestial sphere, I want to talk to you about constellations. Constellations are really how we are able to navigate the night sky. Constellations, however, have some things that we need to know about them before we're able to really kind of talk about them in detail. Alright, some of the things I want to cover really quick. We're going to talk about constellations themselves, the names of the stars that make those constellations and how they're named, the brightness of stars, because there's different degrees of brightness when we talk about a star, and then the magnitude and intensity of them. Alright, so constellations. It goes back to ancient times, mainly the Greeks and the Romans, who looked up at the night skies and they saw stars. Those stars that they saw, the bright ones especially, now they started putting together into little groups. And those groups they made into animals or mythological creatures, whatever it was in their culture, that's what they decided to identify. Now, they weren't the only ones to do this. Greeks did it, Romans did it, and the ancient Chinese actually did this too. Some examples of this would be like Andromeda. If we take a look at the Andromeda area and Pegasus, of course, these things are areas. Now, look, if you look at these stars, you can tell they really don't look like much of a figure of any kind. Another one that's kind of funny about this is if we look at the Big Dipper and Little Dipper, what we call the Big Dipper and Little Dipper, the Greeks actually called Ursa Major and Ursa Minor, and Ursa means bear, so you had Big Bear and Little Bear. Uh, but the funny part of it is when you start looking at the bears and this long handle, what we call a dipper, ends up looking kind of like a tail on a bear. And if you've ever seen a bear with a tail, I've never seen one. So it makes it kind of funny. Anyway, these are some examples of this. You'll notice that the great square of Pegasus right here and Alpheus, this star is shared by both Andromeda and Pegasus. So sometimes they overlap just a little bit. All right, when we look into the night sky, we see through our atmosphere. And these look like some of the nearest stars that are closest to us, and of course you can see where Earth is. However, sometimes some stars are farther away. Depending on how bright they are, they may actually look dimmer or the same. So these stars are sometimes close, sometimes far. But they form this image that we look at, say, for example, Big Dipper, Little Dipper. A couple of them stars are really far. In fact, the very end handle in the Big Dipper is actually a twin star. But if you look at it with the naked eye, you can't tell that there's two stars there. So, not always a flat surface. We use the celestial sphere and imagine it as a flat surface, but it really isn't. It's just kind of a bubble we look at. But when we look at the stars, they're at varying degrees of distance. So don't let that fool you. Just because we use the sphere, it's just an imaginary tool for us to help us understand what we're looking at. All right, in constellations, these are all named according to the brightness of the star. The brightest star gets the Greek letter alpha. The second brightest would be Bravo. So, or Alpha and Beta. I'm sorry, not Bravo, Beta. Alpha and Beta. Those two stars, and then it continues through the Greek alphabet. So, for example, if we look at Orion, Betelgeuse is actually, or Betelgeuse, some would say, is the brightest star, which is also a red star and a dying star, no less. It's only got a couple million years left, so it's not going to be around too much longer. His shoulder is the brightest, so it's designated as the alpha. The next one would be the beta star, which is the second brightest. In this case, is Ringo. When you start working on your constellation lab today, you're going to see that these two stars become our major starting points. They're easy to spot, especially in the night sky. All right, the magnitude scale. Hippocrates is the first one that came up with this. He came up with the idea that the very brightest star would be the first magnitude. So we look up in the night sky, Betelgeuse would be, for example, a very bright star. So he gave that the magnitude of 1. Stars that are very faint, that you can see in the very distance of the unaided eye, especially out here where we live in Kingsburg, if it's dark, you can see very faint stars. Those would be the 6th magnitude. When you start getting towards the city with the light pollution, you're not able to see as much. So sometimes the 6th magnitude is not seen. About as far as you can see on a good clear night in the city would be about a magnitude 3 or 4. So we can't see that well. So being out here, we have the advantage. Hopefully later in the semester when we go out, take a look at some of the stars, have a night gazing party, we'll be able to see some of these faint stars on a good night, good, clear, cold night. When it's really clear and cold, we can see the most. That's the best time. All right, so taking a look at this, you can see how this scale breaks down. So get a little more detail. Here's Betelgeuse again and Ringo. Their magnitudes are showed, and you see the magnitude for Betelgeuse is 0.4, and then the magnitude for Wrangel is 0.1. So that's actually backwards from what they normally show, but that magnitude is how we scale it. So this bright intensity ratio is how we show. All right, on the scale, these are how some of the brightness shows. Once they put together the scale, they realize that, oh, there's some other things out there that are pretty bright too, like the sun, or at night we see the moon. So what they did is the negative numbers actually became brighter. So 0 is the starting point now. So Hippocrates started with his 1 at Betelgeuse, but now we go backwards. So if we look back, Sirius is actually brighter because he had to name that one. So it becomes like a, what is that, a -2 or so. Venus, when it's very bright, and you can see that in the eastern sky or western sky, it's almost a -5, very bright. -11 or 12 for the moon, and of course the sun becomes a -26, which is the brightest. I hope that this is pretty clear to you. We'll talk about a little more in class. Magnitude scale is important, and it has to go with your celestial sphere and how we look at these things. In your constellation lab, we'll get a chance to try to put together some of these constellations. By the way, this is a challenging lab, so check it out. We'll see what we can do. Hey guys, Mr. Diamond here again. So once you've taken your notes on the Constellation Lab, I want you to practice a skill called star hopping. Now, star hopping is not an easy thing to do in this night sky, but if you practice on this paper, it usually helps out. Since we're starting our observations, you have your star chart. What you're going to need to do is pull your star chart out, the one you made, the one with the cardboard and the wheel that turns. Once you've got that, what I want you to do is I want you to turn to that and look for Orion. If you notice here, Orion is the very first constellation, and it has a big star with it, 2 big stars actually. One's Betelgeuse and Ringo. With Betelgeuse, that's a major red star that's actually a dying star. It's supernovaed several million years ago, is bright red, and you can spot this at night. When you look at it, it looks very red. So what you're going to do is you're going to take it and try to start with Betelgeuse. Once we do this, let me move down. The next page, you'll see a star field. This star field is exactly what the night sky would look like. It's easy to spot Betelgeuse, first of all, because Betelgeuse is right here. If you see, it's that one that I'm highlighting for you. And there's the belt right there with Orion. So you got a good idea. I can tell you right now that this is Orion's right shoulder, and this is his belt. So he's almost standing on his head for this in this star field. From there, I want you to start putting together and tracing together what Orion might look like. The next major star you need to know about is Sirius, right here. Okay. Once we get to class, we will identify the Small Dipper, which is Ursa Minor, Drago, which goes right through here, and the Big Dipper, right about here. Once we've got them identified, you're going to be able to star hop to the next star moving over. And a star hop is just like this. If I wanted to find Betelgeuse, and I knew where that was at, that would be Betelgeuse. Betelgeuse takes a small hop. I know that it's going to be just north, so I look north to the next brightest star. By the way, the bigger the star is on this paper, the brighter that star is in real life. All right, good luck with this. Give it a try. We'll talk about it more in class.